Hello everyone, I am Snigdha Kakkad and this is my channel Accelerate AI Careers. Today I have brought a very interesting LeetCode problem. It's a hard level problem, LeetCode 52 and Queens II. This problem is really important because it has been asked by several companies in their interviews in last 0 to 6 months, some of them being Meta, Microsoft, Google, Bloomberg, Amazon. Now let's see how is this question solved, how is it different from the previous LeetCode problem which we have solved, which is nqueens 1. And what's our intuition behind this? So this question, you have been given an nqueens puzzle here as shown in example 1 on the left pane, where you have n by n chess board and n queens. You have to place those queens in the board such that none of the queens can attack each other. Now in nqueens 1 problem, you returned the distinct solutions possible, distinct combinations possible of the matrix such that the queens can be placed while they cannot attack each other. In this solution, why is it a little bit easier, I would say, than the prior question? Because you don't have to return all the possible solutions. Instead, you have to return the number of distinct possible solutions to the nqueens puzzle. Basically, if you would have taken length of the matrix solution which you got earlier, it would have given you the number of distinct solutions. But I would try to solve this question from the very base and see how we can solve it. When we say that none of the queens should be able to attack the other queen, we mean that in chess, for those who have not played chess before, a queen can attack in either of the 4 directions, that is up, down, left, right. Also in diagonals, that is a positive diagonal, that is this direction, any of these, or negative diagonal, that is this direction. You have to place the queen such that it is not in direct line in the same row or in the same column or in the positive diagonal or in the negative diagonal. And that's the entirety of this question. One such solution, for example, 1 has been presented here in the right pane. You can try solving it yourself to understand the brute force approach for the question. The brute force approach would be basically that you start from the 0th row and then you assign the queen to some position. And then you move to the next row, rule out the same row number, rule out the same column number where you placed the queen before, and rule out the diagonals where you placed the queen before, and you have the remaining cells, and you place your next queen in one of those cells. And then you go to the 3rd row. Same ways, you rule out the prior used column, row, positive diagonal and negative diagonal, and then use the remaining cell. And that ways you will do till the nth row. And if you are able to reach the nth row, place the last queen successfully, that means you have found a successful combination. And you can increment your result. That's your approach basically here. So you are placing n queens. For each queen, you will have how many choices in worst case scenario? For the first queen, you will have n-1 choices. For the second queen, you will have n-2 choices. For the third queen, you will have n-3 choices. If you multiply all of them, it comes out to be n factorial, and you are placing n queens in them. So time complexity would be somewhere around n factorial into n. Now some solutions which we might do, the time complexity could also be n raised to power n into n. In those scenarios, we are not ruling out any of the choices. We are going for n rows and n columns, and that's why n raised to power n is your time complexity multiplied by n queens which you are trying to place. And that is the solution I'm going to solve here. The approach which we are going to use to solve this question is backtracking. What I mean by backtracking is that, say, suppose you decided that you will place your queen in the 2nd cell here, and then in this 3rd cell, you can rule out this column where this queen has been placed. You can rule out this row, which there it has been placed, the positive diagonal and the negative diagonal. So the remaining cell is this. You place the queen here. Now in the next cell, you will search for all the possible options where it does not collide with the prior 2 queens placed, and then next cell. And then you will backtrack. You will remove the queen from the 4th row and try to place it somewhere else. Same ways you will do with the 3rd row queen. Same ways you will do with the 2nd row queen and the 1st row queen. That ways you will try to find an alternate position where it can be placed, which is different from the prior combination, and still none of the queens are able to attack each other. So you are basically backtracking from the prior solution which you obtained. And that's our approach here. Now, how will I solve it? I'll basically have hash sets. I'll have a hash set to track the columns I have visited before. I don't need a hash set to track rows because I will be backtracking row wise. So if I have visited row 0, I'm not going to put another queen in the same row. I'm going to move to the next row. Hence, I don't need a set for rows. And then I'll also need two sets, one for positive diagonal, which I'm calling these diagonals, and one for negative diagonal, which I'm calling these diagonals. And for positive and negative diagonals, you would say for row and column, it's easier. For row, it's just one increment here. For column, it's one increment here. But how do you track positive diagonal and negative diagonal? So that's the intuition behind it. Positive diagonal, you will always find that r plus c remains the same. And for negative diagonal, you will find that r minus c remains the same. Let me explain it to you with an example here. So in example 1, this is your positive diagonal, like I'm saying. You can call it any other name, but this is somewhat positive diagonal. This is another, this is another. Here your column is first and your row is 0. So 0 plus 1 is 1. Here your column is 0 and your row is first. So 0 plus 1 is 1. So your r plus c still remains same. In this, your row is 0 and your column is second. So r plus c is 2. Here, your row is 1, column is 1. So 1 plus 1, 2. R plus c, 2. Here, your column is 0 and your row is 2. So 2 plus 0 is 2 again. And r plus c remains 2 in this. Same ways, if you compute for this, here, your column is third and your row is 0. 0 plus 3, 3. Here, it would be first row, second column, 1 plus 2, 3. This is second row, first column, 2 plus 1, 3. This is third row, 0 column, 3 plus 0, 3. So r plus c remains the same. Now for negative diagonal, you are going always one column increase when you are moving here and then one row increase. So your r minus c will always remain the same. For example, here, your row is 3 and your column is, your row is 0 and your column is 3. So 0 minus 3, minus 3. Now there is no negative diagonal corresponding to this. For this one, your row is 0, column is 2, 0 minus 2, minus 2. Your row is 1, your column is 3, 1 minus 3, minus 2. Same ways for this one, your row is 0, column is 1, 0 minus 1, minus 1. Your row is 1, column is 2, 1 minus 2, minus 1. And r minus c will remain minus 1 for this. Same ways for this one, r minus c will be 0. You can compute it yourself and see. So the intuition behind that is I will always track r plus c for positive diagonals, r minus c for negative diagonals, and column c for columns. And that's how I will use my sets. Now I'll start coding it. If you have any questions, pause the video, ask them in the comments. I'll be happy to address it. If you like my daily LeetCode videos and my way of solving problems, hit that subscribe button now before you watch the full solution. It really helps me going to make videos again and again and help you master your journey, not just in LeetCode, but also in your journey of your software development and AI careers. So let's start coding this question. So I will first initialize my column set where I will track all the columns which have been visited. Then I will also initialize my positive diagonal set where I will track r plus c values. That is any of the positive diagonals which have been used before, any one of the queen has been placed before in that diagonal. And I'll initialize my negative diagonal set for r minus c values for tracking the same. Now I will initialize my result which will track the number of distinct outcomes possible for that particular chessboard. Now I will write a define backtrack function where I'll pass rows. That's why I will not have any repetition in rows because I'm going row by row. My base case would be if I have reached the nth row, that is I've reached the last and I found a good combination, decent combination. So I'll initialize my result here, non-local result, because it was initialized outside this backtrack function. That's why. And I'll increment this result because I found a decent solution here. And I'll return. That's my base case here. Now post that, after I found the base case, I will go for each column in range n and I will check if that column has occurred in column set or r plus c occurred in positive diagonal set or r minus c has occurred in negative diagonal set. If either of these situation is true, in such a scenario, I'll continue. I have to bypass. I can't consider that solution. And then I'll add these values if that is not true and I have not come across either of these values in the sets. That means this is a possible solution. I can consider it. So I will visit them and then I will add those values to these sets. That's how backtracking works. So for positive diagonal, I'll add r plus c. For negative diagonal, I will add r minus c. I think that's the most difficult part of this question, to understand the intuition behind r plus c and r minus c here. If you understand it, then it's a normal backtracking question. And then I'll call backtrack on next row r plus 1 to get the next queen set up. And finally, I'll do some cleanup. Column dot remove the column which I just added. Positive diagonal dot remove r plus c, which I just added. Negative diagonal dot remove minus c. That's how you do the cleanup in backtracking. And finally, you just have to call this backtracking function outside the backtracking, starting from 0th row, and then return the result. This is your entire code. Let me explain it once again. You first initialized all your 3 sets, positive diagonal, negative diagonal, and column, to track which particular cell already has queen, and handle the situation that one queen cannot attack another, and initialize your result value. Then you write a nested backtrack function where your base case is you have reached the nth row successfully and found a combination. In that case, you increment your result by 1. Otherwise, if you have not reached the situation, you will go column by column in n columns, and you will check if any of those values have occurred in your sets. If yes, then you will bypass that solution and continue. If not, then you will add those values to your set that you are visiting them now and call backtrack on next row. Finally, you will do just the cleanup, call backtrack on 0th row outside the function, and return result. This is your entire code. Run it. So the error is with return result. I have to do backtrack here and return result here. It was the indentation error. I'll run it, accept it. Let's submit. So as you can see, our solution is doing quite well here. If you have a better way of solving the problem, let me know in the comments here. I'll be happy to learn from you. If you like my way of solving questions, I'll again ask you to subscribe my channel so that you get your notifications for your daily LeetCode challenge. If you have any question you would like me to prioritize and solve next, let me know in the comments again. Thank you.